Soybean is one of the most important grain crops in the United States. In the southern U.S., many farmers grow soybean on land previously cropped only to cotton. Many cotton-associated pathogens impact soybean, in particular the southern root knot nematode. This nematode can inflict severe damage to soybean, resulting in significant yield loss. Control methods are limited. These strategies include crop rotation, planting crops that are not hosts to root knot. However, southern root knot nematode has a broad host range limiting choices. Nematode-resistant soybean varieties. However, the number of high-yield producing resistant varieties are limited. Nematicide applications such as the pre-plant fumigant Telone 2 or seed-applied nematicides. Seed treatments can provide short periods of production if nematode pressure is low, but are not as effective as Telone. However, Telone supply is limited and application costs are high. The plant pathologists from the mid-southern U.S. are focused on sustainable nematode control. For example, if nematicide applications are limited to specific areas where damage is severe, then the volume of nematicides used can be reduced. This is possible because nematode populations are dependent on soil texture, which is quite variable in many fields. The southern root knot nematode prefers coarse, sandy soils, which typically had a history of cotton production. A study was conducted in the southern U.S. comparing strips of soybean, either non-treated or Telone-treated, with or without a seed-applied nematicide. Using two different nematicides enabled the team to determine their relative effectiveness. Electrical conductivity was used to create soil texture maps. Electrical conductivity primarily measures soil salt concentrations, which are strongly related to soil texture. The finer the soil texture, the greater the salt concentration, resulting in greater electrical conductivity. Soil samples collected from each field help determine the abundance of specific nematodes present. Yield maps were created to establish the relationship between yield, soil texture, nematode population, and nematicide treatment. Results indicated that in areas where the soil textures favored root knot nematodes, Telone treatment significantly improved soybean yield. However, nematicide application did not affect yield where soil type did not favor the nematode. Therefore, site-specific applications of Telone can be used to control root knot nematode and maintain high soybean yield.
Nematodes are responsible for heavy yield and crop losses in fruits and vegetables all over the globe. Tiny eelworms, like the root knot nematode, live in the soil and the larvae attack plant roots. Nematodes penetrate the root, start to reproduce, and cause root galling. They suck water and nutrients from the root system. Infested plants suffer and show poor growth. Fluopuram from Bayer stops the attack. The active substance is applied to the soil via a drip irrigation system, allowing it to precisely target the root system. Treated nematodes rapidly become paralyzed and remain needle-shaped until they die off. After the fluopuram has been applied, Bayer's biological nematicide, BioAct, destroys the remaining nematode eggs. Like fluopuram, BioAct can be directly applied via a drip irrigation system. The fungus starts to parasitize the nematode eggs and prevents the larvae from hatching and infecting new roots. The healthy root system enables good plant growth and high yield production.